Okay. Yeah. Good evening, all. So in the last class, I was discussing about fault tolerant model in Pyspark. When the current RTD is down, right? When the current RTD partition machine is down, then it will deallocate all that and again takes the input from R1 and again recomputes, right? When the previous RTD machine is down, then it recomputes, the execution starts from the beginning. So the process should start from the beginning or from the persisted RTD. If a persisted RTD machine is down, right? Like R3 machine is down, if it is down, right? So the flow will be starting from the persisted RTD or from the beginning. And again, this R3 gets repersisted. Now see one more example right here. Yes. Observe this example too. Excuse me. The same thing I will take. Now try to answer for this. Yes, everyone try to answer for this, right? R1, R2, R3. Yes. This time it is down. This is down, right?
R3. From R3 it will start.
Yeah, where the flow will start from R3, from the persisted RTD, right? Yes, it starts from persisted RTD. Because when R4 is down, then the previous, it should start from the previous, right? Yes. Now, just what is this? Right. While executing R5, while executing R5, while taking input, while taking input from R4, while taking input from R4. If R4 failed, if R4 failed, then the input is taken, then the input is taken from R3, then the input is taken from R3. While executing R5, while taking input from R4, if R4 fail, then the input is taken from R3, which is available in RAM. And reloading R4. while executing R5, while taking input from R4. If R4 failed, then input is taken from R3 and reloading R4 another machine and computing, and provides input to yes, R5. Now see this case 4. Case 4. When two RTDs are persisted. R1, R2, R3, R4, R5, R6. So when two RTDs are persisted, R1, R2, R3, R4, R5, R6. R3 is persisted and R5 also persisted. Persisted means that RTD will be available in the RAM, right? Okay. Now in this case, right? Case 1, case 2, we have got within this again, we have got case 1. If R5 machine is down, if R5 machine is down, if R5 machine is down, what happens? Yes. If R5 machine is down, where the flow will be? Flow will be re-executed. Flow will be re-executed from. Try to answer. If R5 machine is down, flow will be re-executed from
R4.
From
R3.
R4, R3 to R5. automatically R3 to R5 automatically, and R5 will be repersisted. Case 2. If R3 machine is down, flow will be
From R1.
re-executed from, yes, re-execute everyone. Flow will be re-executed from
First one or R1.
R1 to R3 automatically. And R3 will be repersisted. Yes, so these two cases, if the persisted RTD machine are down, right? Yes.
Are you able to hear my voice, right? So,
Yes, what is it?
are you able to hear me, right?
Yes, yes.
Okay, okay. Just for cross checking. Thanks.
Now, importance of persistence. What is the importance of persistence? Here, observe this case 1. For example, I got RTD1, R1. R1 I have got, yes. From R1, R2. From R2, R3. Hello? Importance of persistence, R1, R2, R3, so on, right? So on up to R100.
So here maximum limit is R100.
Example, if you have got a flow like this. If you have got a flow like this, right? Yes. R1 to R100. I'm saying just for example, right?
Yeah, for example, you are saying, but maximum how many are?
So it depends upon the flow, right? This is a very big flow. R1 to R100 means very big flow, data flow, right? So assume that we have got a very big flow. This much big flow you won't get. For example, I'm saying.
But we don't have any limit, right? Yeah.
We doesn't have any limit.
Okay.
During the computation, right? Yes. During the computation of R100, yes. During computation of R100, during computation of R100, if R100 is down, if R100 itself is done, during computation of R100, if R100 is down, okay. During computation of R100, if R100 is down, right? Then try to say, so during computation of R100, if R100 is down, right? Then takes, then try to say, if R100 is down, should I start from the beginning from R1 or from R99?
Yes, it will
R99.
be from beginning if
Do
there
com-
is no persistent.
During computation
If
of
there
R,
is,
until R100 computation is finished, R99 still remains, right? R98 will be removed.
Mhm.
During computation of until R100 computation completed, R99 still remains. Once this
Still
computation is
persists.
finished, then R99 gets removed. But still this computation, it's down. During computation itself, it is down.
Then it will take from R99.
R99.
Then takes input from, R99. And R100 is loaded. Takes input from R99 and R100 is loaded.
Here, do we have any checkpoint or control interval or any mechanism here?
For
Any checkpoints? If I
No.
don't want it down for until R50 or something like that.
no.
Okay.
Then takes input from R99 and R100 is loaded into another machine. And computed. Right? Yes. And now case 2, observe this case 2, right? During computation, right? During computation of R100, during computation of R100, while taking input from R99, if R99 down, then
We'll take from R98.
From R1.
Last persisted.
then
Last persisted RD.
Last persisted RDD or it's starting from beginning. If not persist any RDD.
then R99 can't be loaded. because its input R98, because its input R98 is not available,
So not available means it's not persisted.
See, when during computation of R100, R99 will be available, R98 will it be available? Hello? During computation of R100, while taking input from, when R100 is computing, R19 available, R98 also will be available? No, right?
No.
So,
No, it is down.
so when R99 is down, to compute R99 again, to reconstruct it, you require the output of its input is from R98. R98 can't be loaded because its input R98 is not available. So in this case, flow starts from the beginning. That is,
If there is a no persisted RDD.
in such case, flow starts from the beginning or from persist or from the persisted RDD. Okay. Case 3. Next. During computation of R100, R99 down. Okay. While re-executing, now observe this, while re-execute, okay, it's starting, the flow is starting from the beginning. While re-executing, right? From the beginning. While re-executing from the beginning. While re-executing from the beginning. And while computing R93 and while computing R93, if R92 down, if R92 down, then R95 not in RAM, sorry, R91 not in RAM, R91 not in RAM. So again, flow starts. The flow starts from the beginning. Again, while re-executing. So again, while re-executing and while computing, right? So again, when it is coming, when it comes from the starting, what? Again, while re-executing and while computing, R85. If R84 down, then R83 is not in RAM. So again, the flow starts from the beginning. So the solution for this is so here, if we persist R80, so here if we persist R80, no need to execute, no need to execute from the beginning. So here, if you persist RIT, no need to execute from the beginning. But here also there is one problem, right? If we persist RIT, no need to re-execute from the beginning. But here, but here, if you persist RIT, no need to execute from the beginning. But here, while computing, so still the flow didn't come up to RIT. Assume that the flow didn't come up to RIT. But here, while computing R75, if R74 down, then again flow starts from the beginning. So to avoid this, the best way is persist. The best way is persist for every 25 RTDs. Persist for every 25 RTDs. Or if memory is good, persist for every 10 RTDs. Every 10 RTDs. That is R10, R20. So persist for every 10 RTDs, that is R10 to R90, or R25, R50, R75. Persist for every 25 RTDs, R25, R50, R75. If any R90, R95 is, for example, if R93 is 92 is down, no need to go from the starting. R75 is persisted, right? Somewhere like if R75, R74 is down, or R72, or R65 is down, from R50 you can execute for every 25 RTDs. Every time no need to execute, right? But if you have got good RAM memory, right, then for every 10 RTDs you can persist it. Once the flow is executed, an action is completed. When action is completed, you can unpersist. All the RTDs. Like R10 dot unpersist, R20 dot unpersist, R30 dot unpersist,
Is there any way to persist automatically every R10 interval
Is there any way to?
instead of go manual? Is there any way to be persist automatically in every 10 or 10th hour
No, there is
record
not.
actually?
No. You need to write the code, right? While doing the code, which one you want to persist, say rtd.persist or rtd.unpersist.
Okay.
So here rtd.unpersist. See here rtd.unpersist. rtd.unpersist. rtd.unpersist, right? Persist happens immediately. Unpersist happens immediately. Immediately on demand. On demand. Unpersist happens immediately on. Yesterday I was saying, right? If we say RTD immediately, it will be unpersisted from the RAM. But RTD.persist, if we say RTD.persist, but persist won't happen. But persist won't happen immediately. Persist won't happen immediately. It happens, but persist when it won't happen immediately. It happens during the flow. It happens during the flow. So, okay, this is what fault tolerance model, right? Fault tolerance model in
Sir,
Pyspark.
sir,
Yes.
is there a best practice also to ensure how many RDD persists to be done? Let's say I have 10 RDDs calculated over the flow, or 15 or
It
20.
all depends upon your memory. See, means you have R10, if there are flow is from R1 to R100. If you are persisting 10 RTDs in the RAM, already one RTD is a huge data object. In such case, your total RAMs are going to occupied by a single RTD. RAM capacity for for example, like 50 GB, your RTD one is 50 GB RAM. In that way, 10 RTDs, if you are 10 into 50, 500 GB RAM has to be maintained. But if you have that much of memory, okay, you can persist for every 10 RTDs, 4 RTDs, or for every 25, R25, R50, R75. 50, 50, 50, 150 GB RAM.
No, despite I have more memory, but is it suggested to persist as many as RDDs?
Yes. Why?
It
Because
may take time otherwise.
if you have got a good RAM, means if you have got good memory, then it's fine. Because if the flow is very big, from for example, if you are persisting for every 25, R25, R50, R75. Yet, for example, while computing, if R73 down means again you need to start from R50, 22 steps, again you need to re-execute. But if it is for every 10 RTDs means, if R72 down means, from R70 directly you can execute the flow. Here you need to come from R50 again. So the number of re-executing.
So if the system is quite stable and if I'm doing also the persistent in every 5 RDDs, like 20 RDDs in 100 RDD flow. So does it take extra time also for the persistent?
Persistence, it won't take any extra time. Now we'll see
Okay.
the many examples, many flows related to persistence, right? Persistence, or when a RTD will be persisted, unpersisted will be happen immediately. Whenever you say RTD, immediately it will be removed. But persistence won't happen immediately. See, now discussing about this persistence and what are the rules you need to follow during persistence, we'll be discussing now. Persistence. Persistence of a RTD. What do you mean by persisting in RTD? Persisting in RTD means? Persisting in RTD means?
Storing
Making
into
making
RAM
the,
or disk.
yeah, making the RTD.
Available in the RAM.
Yes, making the RTD available in the RAM. Making the RTD available in the RAM. Even though the next RTD is ready, and computed, the persisted RTD won't be removed. The persisted RTD won't be removed from the RAM. The persisted RTD won't be removed from the RAM.
And sir, RDD 10 is persisted and RDD 20 is also persisted. Then 10 will be removed or it will be in the RAM also, both.
What is it?
If RDD 10 is persisted and RDD 20 is also persisted, in that case 10 will be removed or that will be also in the RAM.
It will be there. All the persisted RTDs will be available in the RAM. All the persisted RTDs will be available in the RAM.
Okay.
Advantage of persisting. What is the advantage of persisting? If a RTD is persisted, the other data flows can reuse. The executed transformation. That is, transformations can be reused. Transformations can be reused. Now, just we'll see rules in persisting in RTD. Now see the rules in persisting in RTD. First one, for persisting in OTD. For persisting in OTD. Observe these things. Next, I will be showing you multiple flows. You need to say it's valid flows or not. For persisting in OTD, at least one flow should be executed. For persisting in OTD, at least one flow should be executed. Understood, right? The first, for persisting in OTD, at least one flow should be executed. Then only the persistence happens. From second time onwards only you can use it. The second, a RTD will be persisted. A RTD will be persisted when first time, when a RTD is persisted, a RTD will be persisted when first time they are loaded and computed. A RTD will be persisted when first time they are loaded and computed. Even though the persist option is provided in the later steps. A RTT will be persisted when first time they are loaded and computed, even though persist option is provided in the later steps. Generally, which RTD? Yes, which RTD will be persisted? The RTD whose output is commonly used by multiple flows. Persist that RTD. We need to persist the RTD. We need to persist the RTD before action is completed. Yes, we need to persist the RTT before action is completed. Before action is completed, we need to persist the RTT before action is performed. The rest. So these things you need to understand, right? These things you need to understand.
So at that point, can you explain the RDD option is provided in later step?
Yeah, I'll come with some examples, right? All these four steps I'll make you understand. So just observe this. I'm copying this. RTD1 SC equal to SC dot text file HDFS file path. SC dot text file, okay. RTD2 equal to RTD1 or RTD3 equal to RTD2 dot filter, RTD4, RTD dot. So here I'm saying RTD3. Otherwise, instead of saying RTD, R1, R2, R3, R4, R5, R1 dot map, R2 dot filter, R3 dot, R4 dot, R5 dot. Here R3 dot persist, I'm saying here R3 dot persist. Where I am persisting? I'm not persisting after this third step. After R5, I'm persisting it. Do you think will it be persisted?
Certainly not.
Will it be persisted? Everyone try to say
Yes.
yes or no.
No, because it will be gone.
We are performed before action, right? We are trying to persist before action.
Yes. Here will it be persisted means see after R5. See when R1, when R2 is ready, when R3 is ready, R2 removed. When R4 is ready, R3 removed. When R5 ready, R4 removed. Now I'm saying R3 dot persist. Do you think will it be persisted?
No.
Everyone try to answer. Will it be persisted? Yes or no?
No.
Based on the steps we have discussed. Ajay Patekar, yes or no?
Yes, based on second step.
Yes.
Yes. It will be persisted. Yes. How come? How come here? I said when one next RTD is ready, previous one will be removed, right? But after R5 it is persisted. So okay, just observe this, right? How this execution is going to happen. Okay. R5 input is R4, R4 input is R3, R3 input is R2. In this way, it is computing that. R1 input is fine. Here we are giving the names R5, R4, R3, R2, R1. But generally, you can give any name. A1, anything, right? Names you can give for the RTDs, not like RTD1, RTD2. So for example, whenever you are saying R5.collect, first it checks from R5. Okay, I need to compute up to R5 and R5 output has to be collected. So from where the flow has to start one by one, it comes from the back R5, okay, R4, from R4, R3, R3, R2, R2 to R1. So I need to start the flow. To execute this R5, it has to get the inputs of all this. So for example, here R7 is there, RR is there. Here RR is there, right? RR is there. RR also R3 dot something. Right? For this executing this R5, to get this R5 output has to be collected. Do you think during this flow, do you think this also has to get executed? Hello?
No, RR is not required in that
To
R5.
execute this, to get the R5 output, I need to collect it. R5 output I need to collect means first R5 who has to give the input to R5?
Right.
R4. But R4 input is what? R3. But RR is nowhere related to this. To get the output of R5, RR is nowhere related. I don't need to execute RR RTD. If RR is giving its output to R4, then I need to. So this is not part of R1 to R2, R2 to R3, R3 to R4, R4 to R5. No RR is no way connected. In this way, many RTDs will be taking the output of R3, many RTDs will be taking the output of R4. Those things, they are not going to get executed in this flow. Only the one to get R5, first R1 I need to compute. Because R5, to execute R5, first R4 to be executed. Then only R4 output is given to R5. R4 to execute, R3 has to be executed. R3 to execute, R1 to be. So this is like a chain. Directly you cannot execute R5, right? Why you cannot execute R5? Directly this file is not taken by R5. If it is taken directly, I can execute R5. R1.collect, I can say. R1 directly taking the file and R1 output, I can get it. Directly R5 can't be executed. To execute R5, again, R5.collect, if I say R1 to R5, everything has to be executed. So whenever you are defining the flow, first it will check from the bottom, okay, from R5, R4. While during the checking process, R5, R3, R2, R1, up to R1, during this checking process, it will come to know which RTDs I need to persist, which RTDs I need to persist during the flow. Which RTDs? Okay. Here I'm writing. Wherever you specify, the persist option, wherever you specify the persist option, it will be persisted. It will be persisted only when it is first time loaded. When it is first time loaded and computed. Once a RTD is computed, right, you cannot go back and persist it. No. Once R3 got execution finished, it's computation finished, you cannot go back and persist it. Once you are at R5 now R5 is computing, but you cannot go back to R3 and persist. When R3 first time loaded and computed only, it will be persisted. Wherever you give the persist option, R1 to R100, I have given the persist option after R99. Try to persist R3 after R99. But okay, you have given the option R3 dot persist after R99. But first, when R1 is loaded, R2 is loaded, computed. Now R3 loading and computing. Now it will be persisted. But you will ask, I didn't do immediately after R3, then why are you persisting immediately after R3? Means during this checking process, which one input is which one and which one I need to load. Should I load R3 or not? To get the output, to get my output, is R3 should be loaded and computed or not? If it is loaded and computed, okay, load and compute, and also persist it, because you are given an option. Wherever you give the option, it doesn't mean that immediately after R3 you need to give the option. Even if you go after 100 steps also, when R3 is getting loaded only, it will be persisted. Understanding? Hello?
Is there a processing difference? So if you
Hmm?
persist it immediately or whenever whenever we need it?
So I said clearly, right, previously, unpersistent happens immediately, but persist won't happen immediately. But without loading, for example,
No, that I understand. But here, if I write persist after R3 is executed, immediately I write persist,
how
or
come?
after R3, after R5 is completed, persist. So is there a technical difference there?
Here, this fourth one.
Yeah. So here, so in the step R3
For
equal
example, once R3 dot collect, if you are saying, means action performed. After that, if you are saying persist, means R1, R2, R3 they loaded and they computed and all the three got removed. Now you are persisting. Doesn't make sense, right? R1, R2, R3 and R3 dot collect, if you are saying, and after R3 dot collect, if you are saying persist.
No, I am saying in the line, so where you have written R3 equal to R2 dot filter. So after that, I will write R3 dot persist. So that is case one.
Yes,
And
you can do it.
secondly, after the line where you have written R5 equal to R4 dot group by, after that R3 dot persist. So this is case two. So is there a technical difference between these two? Defining persist after this line and after that line.
One time you say, 10 times if you say persist, only that will be it will be available in the RAM mode, right? If you are giving persist multiple times also, anyhow, one time only it will be persisted, means it will be available in the RAM.
No, not mentioning two times. Either I'll mention there or here. So is there a technical difference?
After R3, if you are giving, after R4, before R3, if you are giving, means it says that R3
No,
is
not
not
before.
defined.
Not before.
One second. After R3, if you are giving, after R4, if you are giving, after R5, if you are giving, after R90, if you are giving, all are same.
All are same. Okay.
But I did not understand if it is if R3 is not available into the RAM, how it's getting persisted. Still I have confused here.
What is it? After R5?
Yeah, if you're doing persist after the R3, that makes sense. Like the RDD is going to persist into the RAM. But if you do and just now you're written the R3 dot persistent after R5. How it's getting persist into the RAM, because R3 is removed in the earlier steps only from the RAM.
Here,
That I didn't understand here.
whenever you say R5 dot collect, then immediately R5 dot collect means the first one it's R5 dot collect means first one it is going to see is this step. It is going to see, it is going to first scan this statement. Okay, this one, okay, R5. So for
Scanning of
example,
R3, scanning of R3 dot persist, it will check whether R3 is present or into the RAM or not.
one second,
But
very simple logic. So what happens is, whenever you are saying R5 dot collect means what is your observation here?
this action performed right in the last.
For example, S is there, R is there, D is there, L is there, M is there, N is there, P is there. This L, what is this? L. F is there. See this flow once. F dot collect. Am I performing an action? What is the flow? How the flow executes?
SDL.
Directly it will go to S. First you need to say, okay, from where I need to start the flow? From where I need, for example, this is persisted. Because it is used by multiple points, it is persisted. So I want to check directly. You cannot, whenever if a F dot collect, don't immediately go from the start of the flow. Don't you check whether which is the RTD which is available, persisted RTD? This is also, assume this is also persisted and also persisted. So F dot collect means immediately don't come into the conclusion, immediately start the flow from S. No, don't do that. Means you can start the flow from D, right? Already it is available in the RAM. If it is already persisted, then why you are starting from S? How will you come to know? Okay, immediately if N is persisted, this is nowhere related to my flow. So first I need to check from where I need to start the flow. First, to execute F, what is required? What is the input it has to get from? What is the input of F? Whose output? L, right? L. Okay, to execute F, first I want L output. But L to be execute, right? What output I required? D output, D input, output. During this checking process, okay, from D, okay, if it is D is persisted, okay, if D is not persisted, again it will go from S. So it is just analyzing, okay, from where I need to start the flow. During the analyzing process, it will come across which RTD has to be persisted. Which RTDs has to be persisted.
Yeah, but here in this case, D is persisted. You are saying it will start from D, but in the first time, if not a one is a persisted, so in this case, the flow will start from S, right? Obviously.
Yes, yes.
So
So
that case, it will flow from SDLF or SNPO, then SDLF.
If it is already this flow is executed once means, if it is persisted means DLF you will get.
No, I understood. If not persisted, none of the one is persisted when we do it in first time. So if I want SDLF, it will not go to SNPO, right?
This is nowhere related to our flow.
Okay.
To execute this F, this S output is required. N output is not required.
Okay.
N output is not required, right? So how during this analyzing process, okay, which output size required and which has to be persisted. Yes. So for example, coming to this example, right? Yes. Coming to this example, right? So whenever you have said R5.collector, it comes across all these statements or not. Execution starts, it comes across all these statements. It comes across all these statements. And first R1 loaded. Okay, now check this, right? Okay.
So for every process,
first R1 loads. Next, R2 also loads. When R3 is loading and when R3 is loaded and computed, immediately it is there is a instruction given here, persist it. Persist it.
Means after third statement, it will directly go to
wherever you give the persist option, after R3 or R4, wherever you give it, whenever it is first time loading, you are given the persist here.
means it will directly jump to the second last step.
It won't go there.
Then you are saying that when R3 gets loaded, then it will directly go to the persist.
For example, I'm asking for a labor example. I will give you. I'm asking you to deliver 4 products at 4 places. I'm asking you to deliver 4 products at 4 places. And during this, after the third product, after delivering the third product, go and visit your grandmother beside her. So what is it? First, when your execution is started, R1, R2, R3, R4, that during that execution process only, you are going to do that. Here also, just we are instructing this, okay, before this flow is executed, okay, persist this R3 during the flow. And wherever you give that option, right, wherever you give, yes, R1, R2, R3, after R3, persist it. Whenever this R3 is loaded on it, will be persisted. Wherever you give that option after R3, whenever it is first time loaded only, it will be persisted. Once this R3 execution is finished, so don't think what is your point of view is, okay, after R3 computed, R4 computed, R5, R3 won't be available, right?
Right.
R3 won't be available. What is your point of your understanding is, okay, when you came to R5, R4 also removed, R3 also removed. Now you are saying R3 to persist.
Not possible. Then.
Right? R3 can't be persisted. But here, you are clearly instructing here before the execution started. Still execution not started. See, these RTDs where they are loaded, nowhere they are loaded. Nowhere they are stored. They are not stored in the RAM. They are not stored anywhere. They are just declared now. Now, if you see this, clearly you have given instruction, right? First load R1, next R2, next R3, next R4, next R5. Okay. Up at R5, you stop it and just collect this output. But here there is one more instruction given. Persist R3 means persist R3 means one more instruction given, persist R3.
Means, sir, when R3 gets loaded, then directly it will go for the persistence of R3, and after that it will go for the R4, na?
So when R4 is loaded, R3 can't be removed from the RAM. What do you mean by persist? What do you mean by persist?
Means that will be saved. It will be available in the RAM.
When R4 is loaded, R3 is not removed from the RAM.
Right.
That is what persist. But even though if R4 loaded, still if you are removing R3 means what is the use of this statement? Giving this statement. Okay, to make you understand much better, just observe this, right? The execution flow, the flow execution, right? Observe this, the flow execution.
So
If
is there any
after-
technical
after-
difference? So
After
just
R90, 1 second, after R90, understood, it's a lazy evolution, follow will only start when action is performed. So analyzing, it will analyze from the bottom. So it has to check, right? It has to check the last RTD output input from where I need to get. For that, from where I need to start the flow, it has to check, right? Where I need to start from the beginning or from the persistent RTD, it has to check. During this checking process, it will come across these statements. During this checking process, it will come across these statements. And when it comes across, right, when RTD by RTD they are loaded, it will persist it during this process. Yes. See, one thing, if I'm giving this persist option, it won't come across this statement. It won't come across this statement. Because collective, if I have said before that, whatever statements it will come across. Here, it won't be persisted, means okay. After action performing, if you are giving means all the RTDs removed. Now you are trying to say persist this. No RTDs are available. But action is still not executed. Before itself, I am giving R3 dot persist. It will be persisted before action.
So will it make any difference if the R3 persistent will give before group by or before flat map or after group by?
After R3, anywhere you give, but before action you give.
Oh, okay.
After R3 and before action, anywhere you give, what happens during this checking process, it will come across. And it will keep in mind, okay, whenever I need.
Okay, just I missed the one point, like RR here, right? You mentioned RR equal to R3, right? Just can you give one line, like what is RR here?
Dot collect. This won't be executed. It's nowhere related. So will it be persisted? Means yes, persisted. So this point is important. Even though the persist option is provided in the RTD will be persisted when first time they are loaded only. When first time the RTD loaded only, the persistence should happen. But after R3 loaded, R4 also loaded, R5 also loaded. Now, if you are saying to load R3 means it cannot go back. The flow cannot go back and again persist R3. No.
Sir, can you explain difference between loaded and computed?
Okay, loaded. Okay. See here, first R1 loaded. See here, all the R1 partitions. So to get R2, right? R1, okay, R2 dot filter. R2 dot filter means the data is going to get loaded into the RAMs and compute that and store that output, whatever that is stored by R3. Loading means data is stored within the RAMs, the partitions, the R2 partitions are divided and stored across multiple RAMs of multiple systems. That is what loaded. After loading, they are executed parallelly. For example, 5 partitions of R2 loaded in 5 machines. That is what loading. And they are executed parallelly, and the results will be collected by R3.
So if I am right, once loaded, the previous R2 will go out, right?
Yes, once loaded and computed, once computation finished, the previous one. Once R3 loaded and computed, R2 gets removed. So here, just that's what I'm going to say here. See this, the flow execution is as follows. The flow execution is as follows. How the flow is going to get executed here? Yes. Okay. The flow execution, first R1, right? Loaded and computed. Loaded and computed, yes. Next, R2. Now R2. Loaded, computed, ready. It's ready now.
Now R1 is removed from RAM, right?
Yes, exactly. Now R1 will be removed. R1 will be removed. R3 loaded, computed, plus loaded, computed, persisted immediately. You are giving, this is nothing but a special instruction given, right, to persist R3 and ready. Even though persist is option is given after R5, don't think after R5 only it will be persisted. No. When the RTD is first time loaded into the RAM only, it has to get persisted. Wherever you give the persist options, right?
But here, you mentioned R3 equal to R2 filter after R3 persist, you mentioned after R5 equal to R4 group by key, right? But once the control will comes to R3 persist, then only it will persist, R3 will persist, right?
See, this order is not followed at all.
Okay.
This order is not followed at all because this order, don't think this order will be followed. After R1, R5 may execute. After R1, some other RTD may execute. Don't think it will follow the same order.
Okay. So you given
that's why I was showing you.
file map.
I was showing you this diagram, right? Here
Yes,
there's
yeah.
R1, R2, R3, that's why. But here in this case, some zigzag SD is there. After SD executed, D after that L. Don't think ABCD is executed in order. My flow, first S executes, D executes, L executes, LF executes. In this way, if 100 RTs are there, R1 will execute, next R31 will execute. After that, R52 will execute, and next R19 will execute. This flow only. R99 got collect, R92, R99 input is R52. R52 input is R31. R31 input is R1. That is my flow.
Okay.
Understanding, right? It doesn't mean that you should give in the line in the straight way. So it depends upon which RTD's output you want to collect. That RTD input, it will check it. It checks, and during this checking process, if anything has to be persisted, it will persist it. So R1, R31. If R31, you have given any instruction to persist it, yes, if you have given means it will be persisted. Where you have given immediately after R31, if you R31 dot persist, if you have given, or after R70, if you have given R31 dot persist, it will be persist when it is loaded. R31 is getting persist. Yes.
Can you go to one's notepad, please?
What is the technical difference if you do R3 dot persist? So loaded, compute and persist immediately and ready. So filtering operation on R2, you are performing filter. You got R3. R4 you got. So here filtering, observe this, filtering only, but only, for example, filter only males. That is R3. From R3 again, you mapped something. Same that R3 number of records, how many records are there in R3 and R4 also whenever you are mapping something, the same number of records will be there. Filter, you won't see the same number of records. R4 dot filter again, if you do, again we're doing some more filtering. Still that number of records may decrease. Right? So here R3 loaded, completed and immediately and ready. Next. Now R2 gets removed. Now all this finished. Now R2 will be removed. Next. R4 loaded, computed, ready. Loaded, computed, and ready. Now R4, now when R4 is ready, R3 is not removed. R3 is not removed. Clearly, you are giving an instruction here. Persist R3 and don't remove it. Whenever you are performing, whenever you are making an action, before action, clearly I'm saying that, before action only I'm saying that, persist R3 and don't remove it. This statement, wherever you go, it works. After R3, after R4, after wherever, but before action, you need to say. Once this action execution totally completed, no RTDs remains. So before action only, you say which RTDs. Here, persist R2, persist R3, all statements you give here before the action. So what happens? Whenever R2 is loaded, it will persist. Whenever R3 is loaded, it will persist. Once the flow is executed. So 1 second, R1 to R99. So first, when the flow is executing from R1, which RTDs has to be persisted? Already the instructions are given, right? Before the action, what instructions are given, which RTDs to be persisted? Now it will persist. So at line number 30, I've given one RTD. Of line number 50, I've given one RTD. So I give an action at 70th line, I've given action. Before the 70th line, how many RTDs persist are there? All those will be persisted whenever it is first time loaded. Yes. Okay. So R4 loaded, computer ready. Now R3 is not removed.
So what is the recommendable way of giving that persist here after the immediately R3 is calculating, or it's at the end of that before action perform, or the
immediately after R3, for example, this is third line. At 20th line, there is some RTD which is using R3 output. At 50th line, there is some RTD using R3 output. At 70th line, there is one RTD using R3 output. Again, at 85th line, there is one more RTD. So these many RTDs, they are using the output of R3. Now I'll come to know, okay, I need to persist R3. At 95th step, I'll say R3 dot persist. Understanding? Immediately after R3, how will you come to know which RTDs are using R3 output?
Right.
Or R4, whose output is mostly used until the flow last, I cannot say, right? So that is, you can say after R3 also, but after at the up to last before action performed also, I can. R5 loaded, computed. Now see, loaded, computed, ready. Loaded, computed, and ready. Now R4 will be removed. Now R4 will be removed. So simply this statement, to make you understand this statement, R3 will, when first time they are loaded and computed, even though the persist option is provided in the later steps. Yes, even though the persist option is given in the later steps. So understood, right? Now R4 will be removed. When action execution is completed, when action execution is completed, then R5 also removed. Then R5 also removed. Then R5 also removed. Right? Now R3 available in RAM. Now R3 available in RAM. Still, if any other flows, if you are triggering, this R3's output can be reused. Understood, right, everyone? Any queries in this? Steps in RTD's persistence. These are the steps in RTD's persistence. Means we need to persist before action only performed. After action, if you are persisting, right? Once the action completed means no RTD in the RAM. Later, if you are saying to persist in RTD, they are not available. So before action only, you need to say. Okay. Thus, the RTDs whose output is commonly used by multi-users, but they persist that. When first time they are loaded and computed, then even first. Later, okay, understood this, right? This and this is what fault tolerance model. Fault tolerance model and steps in RTD computations. Yes. Once you go through all this, right? Next week, I'll be just going with the practical part, various inbuilt transformations actions. And there are some small topic like where you can persist in memory, in disk, memory and disk. Different persist options are there. Some examples I'll show you more on this to make you understand much better in this persist option. In Pyspark, two main features. One is persistence, one is in-memory computation. Right? Yes. Already executed transformation we are reusing, right? So decrease the number of steps. So this notes, entire notes are forward. Okay. Now itself, I'll keep in this chart. Okay. 1 second, right? 1 second. I will create a WhatsApp group for this Pyspark separately. Yes.
And sir, we'll get the software next week in the NVM.
Yes. Yes.
So next week, are you going to tell the installation software, those things?
Yes, yes. Once, okay.
Practical.
Do one thing. I'll be forwarding some. So okay, already who are already doing Hadoop, right? The same VMware software where you can work with Pyspark and Spark, everything, right? Those who have already the learning Hadoop, right? Already I have provided the software. The others who have joined for Pyspark, right? Who doesn't have the VMware what I have provided. So I'll be forwarding to your Google Drives. The online team will be forwarding your mail IDs, Google Drive. I'll be forwarding. Okay, 1 second.
Could you please share the document to us, like notepad?
Yes.
Thank you.
1 second. I'm forwarding that WhatsApp link. I forwarded, right? Once, check it. I just forwarded a WhatsApp link in the chat. Just click it and get added into the WhatsApp. Pyspark.
That's please share the note, document.
Yeah, 1 second. I'll forward that. Okay, just check this and we'll go through this, right? All this what we have discussed till now. Okay, so we'll meet next, right? 6:30 Pyspark class, 6:30 next Saturday. So we'll just go, I'll discuss some more and go with the practical part, right? Fine, I'm stopping for now. We'll continue next Saturday. So everyone got added into the WhatsApp, right? Yes.